Hi, welcome to my CSC 1024 Programming Principles project, the Mastermind computer game. My name is Alexander Wong Jun Kit, student ID 20007415, taking the program of computer science specializing in data analytics. As you requested, Mr. Matthew, these are the pictures of me. If you ever happen to see me in campus, be sure to stop by and say hi. Next, the introduction of Mastermind. You have tasked us to do this project on the 15th of June, giving us a time period of 1 month. The objective of this project is what I assume to be is to test the programming skills and knowledge of students as well as their logical thinking skills as well. The bit of history on Mastermind is that Mastermind is a code-breaking game for 2 players. It was originally invented in the 1970s by a guy called Mordecai Merry-Rowitz. Next, how to play the game. Well, it's a bit hard to show you on presentation slides, so I'll take you to the Python program. Here is the Python program for the Mastermind game that we had to do. Overall, this program is pretty long, and before we start to show off what the program can do, I've added a bit something extra, which is the print color code to print the 4-digit randomizer from the list, so it will give us a much easier time for demonstration. First, when you start off, you can see the title of the game, Mastermind the Color Guessing Game by me. The instructions, you are required to guess the 4-color code that I'm thinking of. Will you be able to guess it? Put it longer a bit, yeah, that would be better. Input your guesses one by one to obtain the correct sequence to win the game. The code can be inputted as R for red and so on, with orange for O, yellow for Y, and green, blue, and purple. Examples are shown right here. The colors can repeat itself, so you have to be careful, and you have 10 tries to guess the code. Good luck. Press Y to start the Mastermind game, and start. Press enter. The code, as you can see, is the randomized one, is Y, Y, R, and P. Round 1. So we can guess around Y, Y, R, and then let's just guess B. As you can see here, there are 3 exact, and the last one I messed up on purpose is to show off that it can be exact. Now to show off about close. I'll do Y, Y, P, and R. As you can see, I messed up P and R, but they are both correct, so it's 2 and 2. Finally, I shall show off when I guess the code correctly. Y, Y, R, and P. It will show you the message of, well done, you've cracked the code in under 3 guesses. As you can see, the rounds slowly increase over time, and it will tell the user the final code here. Y, Y, R, and P, the final color combination code. Here is the looping mechanism to show that, do you want to play again? You can type yes or no. If you type yes, why? You'll restart the game, and you'll be given a completely new different code, as you can see. Round 1, let's just go for it and type. Let's just try to lose everything. All right, so let's just spam R all the way. You have 10 tries, so as you can see, the numbers of rounds go up 1 by 1 over time. And when you get to the 10th guess right here, for example, let's say you can't guess it within 10, it will show you game over. The code was this, meaning the player has lost. Would you like to play again? Yes or no? I would say no, and the program ends there. Alright, we're back from the Python program. Now, to answer the questions, we shall move forward in the presentation. The question 4 is, how do you design the interactive user menu to help users play the Mastermind computer game? Well, my answer would be to provide them with thorough instructions on how to play the game with the print mechanism to just type out whatever instructions you want them to do for the user interface, as well as the different amount of rounds, the different colors that you can type in, as well as that. Question 5, how do you apply lists in Mastermind computer game? What kind of computational problems where lists are helpful for problem solving? Well, the different amount of lists that I've used, for example, color list, I can list different colors for red, orange, yellow, green, blue, and purple. The list for color code is the random mechanism of using choice for color lists. And this is for the user input, and the storing for other for the guessing for exact and close. So my answer would be the list can be used for storing data permanently and temporarily. Permanently as in this, typing out. Temporarily, meaning this one can be changed all the time due to the choice. And it can be easily referenced to. Also, it can be used in different functions such as randomizing a list, which is the color code. Next, how do you generate randomized values in the Mastermind computer game? What kind of computational problems where randomization is helpful for problem solving? Well, firstly, what I did was I imported random, and from random, I imported choice. Choice is included right here for randomization for the color list. Choice is imported from random, and it gives the function to randomize the values in color list, yes. For and range is there the loop process. Well, for is, range is there to maintain the value for the number 4, meaning it loops it 4 times. Number 4 is how many times it should loop, yes. So for color code, this is the list of how it should be. And then color code dot append, meaning every time this function will be carried out, one value from this list right here would be added into color code, and it will be temporary, of course. It will change every time. So range is that loop this 4 times. So it could be Y, Y, G, B, P, O, Y, R, and the list goes on and on. Question 7. How do you apply decision making in the Mastermind computer game? Well, I applied this decision making by adding the looping for the exact and close values. Why do you need decision making in the Mastermind computer game? If you don't have decision making in the Mastermind computer game, you can't calculate, you can't determine the user has inputted against your own computer generated color code. What kind of computational problems where decision making is helpful for problem solving? Yeah, it solves the problem, because if you don't have the decision making for the for loops and if, you can't determine the exact and close values as well. And this part right here in the middle is to determine the duplicates, for example, like YYBR, like for example. This is to decide whether it's counted as a duplicate, because sometimes when you key in one Y, it counts as both of the places. So that's one part of it. How do you apply the iterative process in the Mastermind computer game? Well, the iterative process is shown basically everywhere, like the if statements, the if and else statements, the if loops, and the for loops as well for the color code. Why do you need to create an iterative process? Because Mastermind is all about a guessing game, and there are different rounds, and you can't be typing every single round repetitively to make a very, very long program. So looping repeats the program again and again to reduce the amount of code that needs to be typed. And finally, what kind of computational problems where an iterative process is helpful for problem solving? It helped to, well, the looping helped to, as I already explained, to reduce the amount of code that needs to be typed repetitively. If the code can be repetitively looped again and again to show, for example, in the Mastermind code is to show the different amounts of code that you need to type, the input code, I mean. So like the amount of guesses you can input again and again, like for every different round. The first, second, third, and fourth color can be repetitively put for a loop because of looping. How do you apply the user-defined function in the Mastermind computer game? Well, the user-defined function is very useful. It's because it can contain a set of code under one phrase set by the user. As you can see for here, start game is the function where to press Y to start the Mastermind game. I programmed it so it will, if start, when you press Y, it will become true. But else, you'll quit the game. What are the advantages of using subprogram in the Mastermind computer game? It allows to store a subprogram under a defined phrase by the user allows repetitive usage of the same subprogram. So you can use start game many places in the code, which wouldn't make sense because this is supposed to be at the start. But if you code, for example, the color scheme of typing in again and again, you just type this instead of repetitively showing the loop again and again. And it also saves space because it reduces the amount of code required in a program, because you can just store it under a user-defined phrase. Next, what have you learned from the programming project? Well, I've learned many things in the one semester. I've been learning alongside with you, Mr. Matthew, for Python programming, from looping to defining subprograms and problem solving, which is the most important thing, is because you use programs to solve many different problems. What is the different future improvement that you would like to carry out in the next level of designing the Mastermind computer game? Well, I would like to improve the Mastermind computer game by implementing different type of levels. For example, like instead of 4 different digits, maybe there'll be 5 or 6 that the user can select from, and the user can input all 4 of the digits at once instead of one by one. I originally have tried implementing the 4 digits at once instead of one by one, but I found the 4 digit to be extremely more difficult than the one by one. And finally, the last slide is, thank you for teaching us this semester, Mr. Matthew. I would like to get to know you better in campus if we ever happen to meet. And yeah, this is the end of my video. I hope you liked it. Submitting along with this presentation slide, I will be attaching the Python program for you to proof test and see if it works or not. And yeah, thanks for teaching us, Mr. Matthew. You're a good teacher. Love your attitude. Like the anime wallpaper. I watch anime as well. And yeah, see you on campus. Goodbye.